Hello and good afternoon, CTS266 Section 840 students for the spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this afternoon's video tutorial is actually going to be on Cisco Networking Academy Lab 8-1, where we're going to be taking a look at IP SLA, and I'm going to actually break this into two parts. We're going to do the IP SLA part in this video, and then we're going to be taking a look at SPAN, or the switch port analyzer. And we're going to be setting up an RSPAN session. So this is the environment that we're working with, the same environment that we've had pretty much all semester long. The only difference is that DLSWO2 is not in the picture. So those ports are shut down, these ports are shut down, and these ports are shut down. So what we're left with are DLSWO1 and ALSWO1 and 2, and that's our environment. I've got a MacBook hanging off of FA106 here for some IP SLA action, and I've got another MacBook hanging off of FA106 over here. And so we're going to dig into that here shortly. If you're following along, we're actually going to start on part 2. So all of the foundational work has already been done. Connectivity has already been validated as well. So let's go ahead and dive in with part 2. And actually, before we step into part 2, I wanted to bring up, typically when we look at IP SLA, and I thought the book did an amazing job of talking about this, where we're sending ICMP echoes or we're using UDP echoes. One of the questions is always, how accurate is the timing? And so this is from a Cisco Live presentation. And again, you can access all of these Cisco Live documents if you go to ciscolive365.com, and you can create an account for free. But this is a great document from a session back in 2012 at Cisco Live in San Diego. The session number is right down here in the bottom, BRK NMS 3043, and had a couple of slides here. So in the spirit of fair use, we're going to take a look at these real quick. So it says, what's the accuracy? Well, again, with an unloaded receiver, so if we're sending an ICMP echo request over to the receiver or the responder over here, if there's no load, it's a 15 millisecond round trip time. Now, you take that same responder or the same receiver, and if he's got a 90% process load, take a look at the response time we're going to end up with. Because again, when these ICMP packets come in, or I should say the IP SLA control protocol packets are coming in, they are pretty much at the bottom of the pile in terms of being serviced. And therefore, if you've got heavy load, that's going to impact your performance. But what we're going to be setting up in this lab, building on what we did in Discovery 13, is we're going to be setting up IP SLA responders. Now, you can see here we've got the IP SLA sender. We don't have to set this up as a responder, but we want to. And the reason that we want to do that is because IP SLA responders can solve this problem of the responder being under heavy load, or the node that we're hitting being under heavy load. Now, the key thing to remember here is that to be an IP SLA responder, it has to be a Cisco device. Non-Cisco devices don't speak IP SLA. So if it's a Cisco device on the other end, and you've got the fear that maybe it's going to be under heavy processing load at some point while you're trying to gather your measurements up, using the IP SLA responder functionality is the way to go. And here is why. And this is critical. And again, I thought the book did a great job explaining this, but this is the advantage of the IP SLA responder functionality, is that it gives us a mechanism to measure the processing time spent on the receiving router. So the router that is receiving the IP SLA control protocol packets, and again, whether those are ICMP Echo, UDP Echo, whatever the case may be, it's going to insert a timestamp when the responder receives and sends the packet back. And so the received timestamp is done at the interrupt level. And that means as soon as the packet is dequeued from the interface driver, it's got the absolute highest priority over everything else. And again, there's some time stamping that takes place here. Now, when you're using IP SLA, you want to do this for both UDP Echo and UDP jitter operations. And here is why. So if I were to scroll down one more page, you can see that what happens, and the book has a similar diagram where we're using UDP Echo here, and you can see that things are getting timestamped. So T1 is when the packet was sent. T2 is when the packet was received or dequeued from the interface. T3 is when the response goes out. T4 is when it's received back here at the center. And T5 accommodates for, again, if it's a serial, you may have interface serialization that's taking place if it's a point-to-point link, serial interface. And so that's what this T4, T5, and T2, T3 take into account, is that it's received here, but then there's going to be processing time that takes place. And so the difference, the difference between T2 and T3, that's going to end up being the processing time. So you see processing delay on the destination is T3 minus T2. And it's the same thing here. The processing time on the receiver is going to be the difference between T5 and T4. And so with IP SLA Responder, again, if you don't have the responder on, you're not going to get this functionality. And this is what a lot of times you'll see it mentioned in documentation about, oh, IP SLA Responder, there's a benefit to using it, but then it really doesn't talk about, okay, well, what's the benefit? And so this is the huge benefit here, is the granularity in the accuracy of your measurements when using IP SLA Responder, because it takes into account the processing time from when it's received right here on the interface to when it's actually dequeued from the interface and then processed. And the same thing on the responder side. Now, it's not to say that IP SLA is useless without IP SLA Responder, but again, you get more granularity when you're using the IP SLA Responder functionality on the remote side to which you're sending the packets. And specifically, UDP Echo and UDP jitter are definitely, and then you can see right here, they're definitely two beneficiaries of this IP SLA Responder functionality. You can see here that with IP SLA Responder, take a look at how close that is. So, I mean, we're talking 15.3, so a difference of 0.3 with an unloaded receiver, and then at 90% CPU. So again, it's a much more accurate reflection of the actual true round trip time. And the processing delay gets pulled out. And so finally, last thing we wanted to say here, which I started earlier, was that for your round trip time accuracy, always use UDP Echo or jitter with IP SLA Responder, because UDP Echo or UDP jitter will benefit greatly in terms of giving you more accurate results than if you didn't use IP SLA Responder. It says only in this case, processing time spent on the sender and responding routers will be subtracted, and the results are more accurate regardless of the CPU load. And all right, so we can go ahead and clear this. And again, fantastic presentation and slide deck there that's actually available on the site for free if you just sign up for an account. So we're going to start on step 2 here. Now that we've got that background, let's start up on step 2. And I've got to unlock the screen on my MacBooks here. So we're going to configure an IP SLA Responder on ALSW01. So let's get onto the command line here and go from user exec to privilege exec into global config. We're going to say IP SLA Responder, right? And I'll do a question mark here, and you can see that we can set it up for TCP Connect or UDP Echo. Now again, the responder functionality, you don't have to set up the responder functionality if you don't want to, but you're going to get much more accurate results if you do. So we're going to say IP SLA Responder and then IP SLA UDP Echo, and we're going to send this out to IP address 172.16.99.1. And now we're going to specify a port. Now this is going to be the port that we use, throughout our testing. So we'll choose 5000. And again, we're going to actually configure this on both ALS1 and ALSW2. And give me 1 second here. Okay, so we're good. So we're going to make sure we're in the same spot. All right, so let's come over to ALSW2 and let's do the same thing. We'll go from user exec to privilege exec into global config. I'm going to say IP SLA Responder. And then IP SLA Responder, UDP Echo, IP address 172.16.99.1. Port is going to be 5000. Do show run include SLA. And so you can see we've got our IP SLA Responder turned on, and we actually have a setup here for measuring UDP Echo, or by leveraging UDP Echo and who we're responding to. Now, so who is 172.16.99.1? Well, that is the DLSW01. If we scoot over here to DLSW01 and I do a show IP interface brief, so you can see for VLAN 99, that is the IP address here on DLSW01. So now we're going to go over to DLSW01, and we are going to set up not the IP SLA Responder functionality. We're going to set up the IP SLA, basically the measurement or the operation, let's say, the operation that's going to be running. And we're going to be going to the two hosts that we currently have set up. MacBook 1, let's call them MacBook 1 and MacBook 2. So let's get into global config here. Well, actually, we need to do interface. So we'll say IP SLA, we'll simply use number 1. And just like the lab that we did earlier, sort of easing ourselves in there with that discovery activity number 13, you can see that we've got our choices here as to what we want to do. So we're going to use ICMP Echo, and we're going to send that ping packet to 172.16.100.101. And now you can see it takes us down even a deeper level into the SLA Echo setup. Now remember, I would always use owner, right? And so we'll say Travis set this up on 492016. Excuse me, it just gives a little more information that's in there. And then you can put a tag if you're pulling this information with SNMP, and we can just say IP SLA Echo, whatever, right? And then that information would get pulled by your SNMP network management system if that's how you were pulling this information off. So let's go ahead and exit out. So again, we set up the UDP IP SLA Responder functionality on ALS 01 and 02. Now we're kind of changing gears here, and we're setting DLSW01 up with two IP SLA functions that are going to be to ping the two MacBook hosts. But then we're going to set UDP jitter up here in just a second. So we kind of switched gears. We set up the IP SLA Responder functionality, but now we're doing something that has nothing to do with that responder functionality, but we will here shortly. So I'm going to exit out. We're going to say IP SLA 2, because we're going to create 4 IP SLAs here. So I'm going to say ICMP Echo, and we're going to go to the other host, .200.101. And again, you could put your owner in here, put whatever you want. You could tag it with some SNMP information that you could pick up in your tag. And we didn't put, we haven't done any of the lifetime settings or anything like that. So we've got this turned on. If I were to say, you can see the frequency option is in here. So let's load this. I could say every 3 seconds. Oh, less than the timeout. The timeout, I believe, is 5,000 milliseconds. So let's say every 9 seconds. There we go. All right. So now we're going to be looking, and this is basically dealing with the delay, right? So this is going to show us the delay between DLSW01 and the two hosts that we have. Now we're going to shift gears again. We're going to go back to what we were working on initially, which is the UDP jitter, because we want to track jitter. So let's exit out here. So now we're going to set up the IP SLA operation that is going to communicate through ALSW01 and 02 to give us information, I should say through to ALSW01 and 02, that's going to give us information about the UDP jitter. So we're going to say IP SLA 3 UDP jitter, and we're going to go to 172.16.99.101 port, right? That same port number that we were using. And the 172.16.99.101 is ALSW01. And the same thing here, right? You can see I can put owner in here. We could put a tag in here if we wanted to put some additional information, right? The frequency, let's crank the frequency up a little bit, is less than 15,000. Okay, so hold on a second. So we'll say, we'll do every 30 seconds. Make it a little more frequently than it is. All right, and then finally, IP SLA 4. So we're creating our 4th IP service level agreement. We're going to do the same thing as we did before, actually. So we could probably yank this back up here and then say 99.102. And that would be for ALSW02. Now, all of the scheduling we're going to do right now. So IP SLA schedule 1. The life is going to be forever, and the start time is going to be now. And we can actually control A. Well, it's kind of in the middle there. So 2 and 3. So we're kicking all of these guys off right now. So now all of our service level agreements, the IP SLAs, are running. So at this point, what we can do is we can go through and do a quick validation here and say show IP SLA configuration 1. And this is just to see IP SLA 1. All right, so you can see we're still using engine 2. You're using 15 code in class, so chances are this is going to look much different, or the engine is definitely going to be different. You can see here entry number 1, we've got our owner information. Here's this tag that we could pull with an SNMP network management station. What type of operation? It's an Echo. Where is it going? 172.16.100.101. And let's see, we've got our 5,000 millisecond was the threshold. It was, right? Okay, so we've got all of our information here. We could do the same thing for IP SLA. Actually, the question in the lab is what type of operation is being performed with IP SLA 1? Well, we know it's ICMP Echo. So then let's take a look at 3. And so 3 is looking at UDP jitter, right? So we're trying to measure jitter between the distribution layer switch and the 2 access layer switches. And that's the type of operation being performed with IP SLA 3. So now let's go ahead and just on the platform in general, if we were to say show IP SLA application, and I think we saw this earlier, I pulled this up in the previous lab, you can see how many entries we support on this legacy 3750, how many entries are currently configured, how many of those entries are active, and sort of the limited amount of things that we're going to be able to create IP SLAs for. All right, so if I were to say show IP SLA responder, you can see that the responder is disabled here. But if I come over to ALSW01 and say show IP SLA responder, take a look at that. So it shows that we've got the IP SLA responder is enabled. Number of control messages received, 5. Number of errors, none. So it definitely is working. You can see right down here, this is a UDP Echo responder. And so what does that mean? Again, that means that if for whatever reason, let's say that, you know, this host was under a huge amount of stress, CPU-wise, if I were to say show proc CPU, right? And actually, well, let's do a show proc CPU history. Give us a little better idea there. And you can see that over the last 60 seconds, the CPU hasn't gone over 10%. Because again, these 3750s aren't doing much of anything. But in the real world, in a real production environment, if a device is under a serious amount of stress from a CPU perspective, we want to make sure that we've got that IP SLA responder functionality configured on that node if it's supposed to be responding to UDP Echo, UDP jitter requests that we may be trying to measure, because we want to make sure that those packets and that IP SLA control protocol gets destaged off the interface right away. And as soon as it does, it's treated with the top priority. And then we get that difference in the measurements from when it's received to when it is sent. and that allows us, it gives us more granular data. So again, very, very important. So let's take a look at some statistics. So show IP SLA statistics 1. Whoops. Statistics 1. And, oops, sorry, I'm on the wrong switch. Thought it was back over here on DLSW1. So show IP SLA statistics 1. So here's the IP SLA here. And you can see this is our ICMP Echo. So all this is doing is tossing a ping packet over to the host. We're up, right? Latest round trip time. So you can see we've got 1 millisecond here. We can see it's ICMP Echo start time. We've got the latest operation return code is OK, which means it's up and it's working. And this was the default every 60 seconds. So you can see we've only had 5 successes and 0 failures. And that is going to run every 60 seconds forever. So let me clear this out. And basically checking to see, hey, is the reachability there? Now let's check IP SLA 3. As you can see, we end up with a little more information here talking about the jitter and the latency. So type of operation, it's a jitter operation, UDP Echo. Latest round trip time is 2 milliseconds. It's kind of the same thing here. Start time, latest return code, OK. But now here are the values that we're seeing. So number of round trip packets is 10. Here are the statistics we would be interested in, right? The round trip time for those packets, the minimum is 2 milliseconds, the average is 2 milliseconds, and the max is 4. So latency one-way time in milliseconds, number of latency one-way time samples, we've had 10. And source to destination latency is right here. And there is the destination to source latency. Now we'll talk about jitter. We've got 9 source to destination, destination to source samples, and we're seeing that in terms of jitter, the minimum is 0, average is 1 millisecond of jitter, and the maximum jitter we've experienced has been 2 milliseconds. Now remember, jitter is defined as the difference between the latency that we see. So if the first packet we send has a round trip time of 3 milliseconds, and the next packet that we send has a round trip time of 9 milliseconds, what we say here is that we have 6 milliseconds of positive jitter, right? Because the jitter is the difference, the delta between that packet and this packet. And so what we're doing is we're averaging, as we send all of the packets, what is the jitter, right? Okay. Packet loss values were good, right? All the interfaces are up, so nothing's gone wrong there. And then we get the voice score values, right? So if you were scoring for voice or trying to emulate or simulate or get a reading on what would it look like with voice packets, here are the 2 readings that you would get. All right. So let's clear the screen here. And let me double check and make sure that's everything. It is. All right, so what we're going to do now is we're going to disable VLAN 99. And this is going to break one of the IP SLAs. So we're going to go into Global Config, Interface VLAN 99, and we're going to say shut. Now, what this is going to do to IP SLA 3, where we were trying to measure the jitter, is it should show us that we are not connected. It'll say not connect, busy, timeout, back over here on DLS1. So if I were to say show IP SLA statistics 3, latest round trip time, and are we doing this every 60 seconds? And let me make sure, show run include SLA. Let me make sure I've got this in order here. Schedule lifetime now, that's right. Show IP SLA 3, or show IP SLA, and we want to see configuration. Number 1, actually configuration for 3, sorry. Configuration for 3, and it should show every 30 seconds. So it's possible that show IP SLA statistics 3. It's possible I hit it too early. Whoops. There we go. Yeah, I think I was just came in too quick, and then it was still actually up in between the 30-second intervals, because this was what we should have seen for the latest round trip time, was no connection, busy, or timeout, because again, it's not connected. We've taken down the destination that these UDP echo packets or UDP jitter packets are being sent to, and so therefore it's not reachable. If we were to bring the interface back up, then it would go ahead and it would behave as it always has. So let's go ahead and do that. We'll bring it back online. So again, you take the interface down that it's trying to reach, and that's going to break that IP SLA responder. Turn it back on, and everything should work just like it was. We'll come back over here to DLSW01 now, and let's see, and there we go. Return code OK, and obviously we've got some additional measurements here. Took it a little longer. These are a little worse than it was initially. But again, this gives you a great idea and a good understanding of the IP SLA responder, as well as the IP SLA function for UDP when we're taking a look at the UDP latency, right? Or I should say the delay and the jitter. And so this is actually going to wrap up. I think this is going to be a good stopping point here when we're checking between the labs. So yeah, so then we'll make this a two-parter, and the next part we're going to take a look at is going to be a remote span session. All right, thank you guys for watching, and I will see you in class on Monday.